Okay, welcome everybody. My apologies. I was taking the role and finding out where everybody was from. So that's essentially what's going on. Any questions before I get going? Hello, can you hear me? Can someone unmute themselves? Can you hear me? Okay, can everybody hear me?
Yes.
Okay, wonderful. Thank you very much. I just want to make sure it was working. All right, very good. So what I'm going to do now is continue where we left off. My apologies for being a little late for you folks because I was taking the role and going through the role just to find out where people are from, etc. So basically, Anna West, can you please tell me what your major is and where you're from?
I'm a biology and political science major, and I'm from Metro Atlanta area in Georgia.
Okay, very good. Emily, can you tell me what your major is and where you're from? Emily Stanley?
My major is the early entry pre-pharmacy,
Okay.
and I'm from Vaughnville, South Carolina.
Okay. All right, Gabby Payne. Can you tell me where you're from and what your major is?
I'm from Lancaster, South Carolina, and I'm a biology major.
Okay, very good. Kali, can you tell me what your major is and where you're from?
I'm a bio major and I'm from Georgia.
Okay, what part?
Brazelton, Northeast Atlanta.
Okay, very good, thank you. And Katie Hutto. Can you tell me where you're from?
South Carolina.
Where? Okay, you're kind of breaking up. Hopefully you can hear me. Okay, Madeline Johnson, can you tell me where you're from and what your major is?
My major is psychology, and I'm from Pennsylvania.
Where?
Waynesboro. It's like 5 minutes from the Maryland border.
Okay, is that near Harrisburg or is that farther west?
It's central south. So like I'm like, if like Pittsburgh and Philly were and like Waynesboro made like a triangle, I'd be the point of it.
Okay, very
at
good.
The bottom.
Thank you.
Yep.
No, I grew up near Philadelphia. That's why I'm asking. Okay, Shelby, can you tell me what your major is and where you're from?
I'm a international studies major, and I'm from Saluda, South Carolina.
And where's that?
It's about like 20-ish minutes from Newberry, and it's close to Lexington as well.
Oh, okay, very good. Thank you. And this is how I learned geography of new places, okay? I did this in Texas, I did it in Kazakhstan, which is even more interested, and I did it in Iraq too. So it's like, I had students from Anbar in Iraq and from Baghdad and from other places. So it's like I could picture it on my map in my head, and it's very nice to kind of know where the people are from. It's kind of an icebreaker. All right, so very good. So what we're going to do now is start and then continue where I left off. The main thing I want you to understand is what we're going to do today is essentially go up through binary compounds. And I'll use the slides to show you how it works regarding that. And then I'm going to use the board. And then the board part, I will write it up. The rules regarding this fits very well in with what I did regarding the elements. And then I'll give you some worksheets to work on over the weekend. And I want you to complete 2 of the worksheets, front and back, for Monday on all the binary compounds that are on those sheets. So basically that'll be like a take-home quiz thing, and you turn them in on Monday. For those of you who are distance, if you can turn them in on Monday, and when you turn them in, you ask me if you have any questions regarding any of that, and basically I want them complete. But basically, because you're going to open book and such like that, you can figure out what they are. But this is all about skill learning, okay? And then on Monday, I'm going to go over the ternary compounds, which is the second part of naming. That's stuff like nitrates and other things like that, and involves oxygen. And then essentially, we're going to be done the chapter. Now, I haven't decided yet whether we're going to have a test on chapters 1 and 2 or chapters 1, 2, and 3. I haven't decided yet. I'd like to see how people do on it. Yes?
So last class I was here, you mentioned we had to study more stuff in the periodic table.
Correct.
And we're going to have a quiz as well.
Yeah, that'll be on the naming thing for the compounds, because that the whole
That's
point.
going to be on the assignment.
Yes, but it's also, there's going to be another quiz for chapter 2. And that'll be next week. I don't know yet what day. But I'd like to have the quiz be on the binary and ternary, and then I'll decide probably Monday whether we're going to have an exam. Otherwise, we may wait until chapter 3 after that to have the exam. So I have a little flexibility there. Yes. Well, it'll be on naming of compounds, the binary, whatever, as well as the stuff on the periodic table. The periodic table learning, those was to help you get prepared to do the naming of compounds, because it's like putting two pieces together. Okay, so I quiz for that as well as the naming. So that, yes.
How many do we memorize? We were last time we did.
Well, I went up, no, I went up through 50, I went up through 56 and then gave a list of the other ones. So basically you need to check with me or whatever else, because I believe they're in one of the videos later. So they're like a dozen above 56 you have to know, okay? But those will go into the naming of compounds. Yes?
Okay, and for the quiz, we need to know obviously the elements and how to like name binary compounds as well as the lecture notes.
Sure, the conversions and other things that you've been learning in chapter 2. So the quiz will be on chapter 2 essentially, as well as the elements and naming of compounds. So it'll be all encompassing. So basically it'll be a little harder than the last one, okay? But yes.
When are we taking the quiz?
The quiz will be after the ternary ones. Probably, it'll probably be something like Tuesday evening. I haven't quite decided. I'd like to see how people do with the worksheets and whether I need to go another day.
Okay, so it's not Monday.
No, because basically Monday I'm going to cover the ternary compounds, because I'd like you to work on binary ones over the weekend and then ternary. It's better to break it up, okay? And so I may go a little slower than this, but learning the nomenclature, which isn't naming, is quite important for this area of chemistry. So what I'm going to do now is essentially start share the screen. Okay, I'm going to share the screen now and continue where I left off. Okay, this is where I left off last time. Okay, can you folks distance, can you see the screen? Can someone comment? Can you see the screen there?
Yes.
Okay, wonderful. All right, very good. So essentially this is a refresher, this part, a refresher regarding what atomic numbers are. And if you look at carbon 12, the only difference between carbon 12 and carbon 14 is what? Very good, okay? So basically that's the definition of isotopes. That's one of the labs you folks are working on this week, okay? For those that did the virtual one last week, you're doing the atomic numbers one and isotopes today or Friday or the other days. the atomic weights in the mole, the mass of one atom of carbon-12 is defined. This is a definition. This is essentially designed so that 12 grams of carbon-12 is equal to 1 mole of atoms. That's the equivalent of it. So essentially, if you have 12 atomic mass units, that defines a thing. That is what carbon-12 is. If you remember the carbon there, 12.01, that's based on the abundance of what? The different isotopes. So the number below chlorine is 35.45. So again, it's a situation where you've got to start with a standard, and they define it as that. Now, definitions when it comes to chemistry, those are considered facts because they're defined as being true. So you've got to have certain things that fit regarding all these things together. Okay, and so carbon-12 will be represented by this, 12 and 6. I will ask you that on the test to be able to do that as well as the quiz. Yes. I will ask you to do the right. No, I will ask you to do this thing correctly on the quiz or the test. Okay, so you do need to know. Now, why is atomic 12.01? Well, it's natural abundance, and we've been doing that already with the labs, and that's the point of doing the labs and the different weighing that you did of the balls in the laboratory. Okay. The Avogadro's number, 1 mole of any substance, contains 6.023 times 10 to the 23rd formula units. The molar mass is the mass of grams of 1 mole of any element. It's numerically equivalent to its atomic weight. So essentially, the molar mass is the mass of 1 mole of atoms. Very, very important. Now, measuring atomic weight. How do they measure it? Atomic weight? Well, the book goes a little description. You won't get more into this until you take organic chemistry, but they use a thing called mass spectrometry, which essentially uses a magnetic field to kind of bend a thing of atoms that are ionized based on the magnetic field. And the more massive something is, the amount of bending is different in the magnetic field. So basically, you can get a kind of a spectrum regarding what the things are if you shoot those at it. So essentially, you get a bunch of different ions, and they go to different places, and the detector picks up where they are on it. Like, say, for example, here, the mass spectrum of a sample of boron. The mass with boron 11 and 1 of 10. What does that tell you about the number of boron 11 compared to boron 10? Which is the one isotope that has more presence of that? Which one has a greater presence? Boron 11 or boron 10? 11, okay? And that's essentially how the detector works. It kind of breaks down the things because the boron 10 is based on its mass, is directed slightly different in the detector. Now, mixtures and chemical compounds, we've already addressed this a little bit before in my earlier slides, but matter is broken into mixtures and pure substances. Pure substances are break down into elements and chemical compounds. My apologies, everybody. The thing is buggy. Are you seeing things again now?
Yes.
Okay, very good. I already talked to the IT people about this, and this is something they don't know how to fix. So we're going to get a hard wire set up so that I can, so that it won't go out again. Okay, but basically covalent bonds are when you have share, and we'll be talking about covalent and ionic bonds later in the semester. So this portion is kind of is relatively unimportant. Okay, so essentially you share electrons associated with that. The molecules with ball and stick models and models there, we'll be talking about that later on. Ionic bonds, basically with an ionic bonds, they're like the plus part is attached to the negative part. So essentially if you have something like sodium plus and Cl minus, what holds it together? Well, the fact that the opposites attract hold it together, and it gets held together in a crystal. And chemical compounds, when you're talking about salts, go up in a way much like a molecule does. Like H2O is a molecule, and this is an ionic solid. So it's not really a molecule. It's like a framework with the positive regions and negative regions in there. So essentially you have two things regarding each of those. And this is the framework there on that slide. Now, cation charges. This is where you can take out the periodic table. If you have your periodic table handy, on here on the side, this is +1, +2. Column 1 is there, and essentially they easily lose electrons. So those charges of those things on the left will be +1 and +2. If you have your periodic table, put +1 and +2 over the top of that column. Okay, and then +3 over aluminum and boron and such like that. Put +3 over there, and then plus or -4 for carbon, -3 or +5. Let me show you on the board. So you have +1, +2, and then over here you have +3, plus or -4, +5 or -3, +6 or -2, +7 or -1, and then 0. Okay, and so put those over top of each of the different things. And the whole point is when you've got a structure like this, sodium and chlorine like that, this is +1, this is -1. They're in one digit. Or if you have calcium +2 and then chlorine, you need 2 of them to go together. This is the chemical compound. So this is calcium chloride, and we'll get into that later. But essentially, this is what you're going to be doing when you put the pieces together to make up the compound in chapter 3. Yes?
Isn't all the ones in the middle +3?
They could be +1, +2, or +3, or plus all the way up to +7. So the ones in the center, they're more +1 or +2 primarily. But then they can go all the way up to +7 sometimes. And we'll get to that later. That's called the oxidation state. Okay? So essentially here you got a series of those. Those of you who are virtual, go by this slide here. This is +1 here. In between this would be +1 or 2. Okay, and then all the way up to +7. And then this could be +or -4. This is -3 or +5. -2. Oxygen is always -2, except for one exception. And this could be +6. And then this could be -1 and +7. And then this is 0 for the noble gases. So basically what you're going to have to do is combine them based on what the charge is. And if you understand the periodic table, once you put the things in there and start practicing with it, you'll be able to use the periodic table to help you with the charges. Now, one of the things that you need to realize is some chemistry teachers give you a list of ions on a chart and say, memorize this. That's stupid. It's much better to read it off the periodic table because there's reasons for it, and you're going to learn later in the semester to understand the reasons for that, about why it's done the way it's done, okay? Any questions on kind of how that works? But basically it's about losing electrons and gaining them to form ionic bonds. Yes?
Are we just supposed to like kind of
Yes, and that'll come up in chapter 8 and such like that with there, and you'll understand it later. But right now, when we're putting the names and the compounds together, you need to know a little bit, and it's called the oxidation number. And that's why you will always, here, I don't remember your name. You will always have the periodic table handy. So if you practice with it, starting with that there, it'll be in your mind's eye so you don't have to memorize them. I don't want you to just straight memorize them, then you miss the point. Okay? That's a pet peeve I have, is asking students to memorize stuff and they miss the underlying concept about why it is that way. Now, ion charges for this, if you notice, they're -3 here. So that over here, this is +1, +2. This could be +1 or 2, usually, all the way up to +7. And then here, this would be +3, and then plus or -4. And then here you have +5, +6, +7. But you can understand the logic there. Essentially, fluorine, oxygen, nitrogen want to gain electrons. And the reason they want to gain them is because they want to fill the orbitals, but that comes in a later chapter. Okay, and we'll get to it and then it'll make sense. But right now, we're asking you to kind of take that seriously, okay? Now, I'm going to digress from the slides here with this. I do recommend you use the slides. You use the slides to help you, but I'm going to give you a lecture on how I do it. And essentially, I'm going to go to the other ones by Chang. They'll be in the thing too. So basically, there, what I'm going to do with this is essentially shift to the other one. Okay. Now, those of you on the thing, do you understand what I was saying regarding how these things work regarding it? Were you able to follow my logic? Those of you virtual, were you able to follow my logic?
Yes, sir. Everything except for the middle part with starting with all the metals. Do those also have any charges or?
Yes, they'll be plus or minus 2 usually, but they can also go up to +7. Okay. So eventually we'll get to that point later in the semester. But right now I want you to understand it from this perspective. Okay.
Okay. Thank you.
So I hope that's good enough for now. Okay. Let's see. Go forward here. Okay, what I'm gonna do is add slides to this. Okay, I'm gonna write on the slide, everybody. Can you folks see the screen again?
No.
Okay, hold on a sec, I'll share it with you. Okay, can you see the screen?
Yes, sir.
Okay, wonderful. Okay, so what we're going to do first is talk about binary compounds, okay? And binary compounds are relatively simple. Oops. Here's some example of ionic compounds with formula, and you got 2 and 3 associated with these as well. So essentially with these, for example, aluminum oxide has 2 and 3, and then calcium bromide there, and the names that I just talked about. What I'm going to do is teach you how to use them. Okay, so basically what we're going to do now is go through the relationship so you can see how this all works. But this is the addition that I was talking about before. If you have the 2 times plus 3 makes 6, and then the 3 times minus 2, the total is 0. So you want to have it be always be equal to 0 for this compounds. Okay, so here you have a calcium ion, which is +2. And if you look at calcium, where is it on the periodic table? It's column 2. You can find it. And then you can see it's +2 there. And then the bromine is over there on the right, and it's in the -1 column. So if you write that on the top of your periodic table, you'll be able to put the pieces together really easy. Now, this is stuff I taught to my kids when they were growing up in junior high school and even a little elementary school, okay? They kind of liked it then. One ended up being a chemistry major. The other one was history. So I had no idea, but the point is they liked it at the time, okay? So it's not that hard to learn, okay? Now, what I'm going to do now is talk about binary compounds. Now, can anybody give me a good definition of binary? What does that mean? Huh? 2 things, very good. So essentially the binary compounds, there's a bunch of different examples, okay? And the first one is a metal. And where are the metals on the periodic table, folks? Everything on the left. So you're going to have that handy with you, okay? And then a nonmetal. Where are the nonmetals? On the right, okay? So you start with the name of the first one. And I got to have this like that. What is the name of the first one? Sodium, very good. So this is sodium. Okay, and then you have the name of the second one, but the ending is cut off. Okay, so essentially you have chlorine this is cut off, okay? And basically you have the chlorine there. Okay, you have the chlorine here, and essentially the chlorine is the next one. So the name is cut off there. So essentially you have put the chlorine, you start with the first part of it, and then the last part is IDE. Okay? So now I'm going to quiz you on this first number. You didn't memorize anything. What is this? Sodium sulfide, very good, okay? Sodium sulfide. What's that? Potassium phosphide, very good. You just followed the rule, you didn't use a chart. Does that make sense now? It's essentially very straightforward. You don't have to use a silly chart to do this. Now, if you look at in your book as well as the other places, they give a chart, okay? They say learn this. Well, if you understand the rules about why they are, you can name almost anything, okay? So essentially there's a whole variety of things regarding. Okay, my apologies, everybody. Okay, can you all see again? The internet went out again. Okay, so essentially, those of you on the other side, this is that. Oops, go back. This is potassium phosphide. Okay, IDE. From phosphorus, yes. And we'll get to that. That's a ternary compound. That involves oxygen. So we're just talking about binary, and then but you're getting a little ahead, so you're fine. But the key thing is right now with the binary, you've got those related to it, okay? Yes. Yeah, well, you have a metal and a non-metal. 2 elements, the standard ones, yes, they're ides, okay? So it follows essentially the rule. So essentially the rule is you put IDE in there. Okay? So that's the first one. Now, the second one is when you have two nonmetals. Okay? So let's say, for example, C and O. Okay, based on the first rule, only, what is that first compound name? Based on the first rule only. No, based on the first rule only. Carbon oxide. What's the second one? Carbon oxide. Well, obviously that's wrong. You can't do that. So essentially you start with the first one, name, and then you use a prefix. Okay, and then you have the name IDE. So essentially you have two of them together. The name with the pre and then the name "ide," the prefix goes on there. Mono is what? 1. Di, 2. Tri, 3. Okay. What's 4? Anybody know? What? I can't hear you. Quad, yes. Quad, 4. And then pent for 5. Hex, 6. Oct, 8. There's hept in there too, but hept is very rare. And then deca, dec is 10. So essentially you got to learn those. Mono, di, tri, etc. going down. Okay? Now the thing about this one, what is that compound name? This is nitrogen oxide. This is a standard nitrogen oxide. And sometimes the prefix isn't used for the standard. Okay? How about this one? No, where's the di going to be on? Because you can have a prefix here too. Where's the di going to be on? This is dinitrogen oxide. It's also called nitrous oxide, but we'll get to that later. Okay, this is sometimes called nitric oxide. The ic is higher, and then you got nitrous oxide for the next one. Okay, now what is NO2? Nitrogen dioxide. How about this one? N2O4. Dinitrogen. What? Well, there's another term I want you to look up for 4. Quad is sometimes that, but there's another one. Okay, that's your assignment for next time. But basically it goes mono, di, tri, 4, penta, hexa. Now, what? Tetra, yes, very good. The key thing is tetra is in here sometimes. So quadrilateral is 4 sides, but tetra is the third one, okay? That's part of the problem with things, and that's a part of the problem with me being 63. I forgot the stupid tetra, but I turned it into a quiz question for you on the cuff, okay? But the point is, again, these follow a certain set of rules. You had a question, Brandon?
Yes, what is tetra?
Tetra is 4. Quad is also there too, but it's in different contexts. Tetra is the one you use, not quad. In this case, it's tetra. I just forgot it, and I have no clue. My brain is weird at 63 years old. Okay, it's like it flew out the window. So whatever. But basically, I'm flexible enough to laugh at myself and turn a little quiz question, and she came up with it. So good for you. Okay, thank you. Okay, so 2 nonmetals. That's the next one. Now the next one here is when you have a transition metal. Now someone asked about the ones in the middle. Well, with a transition metal and a non-metal, those have another set of rules. So say, for example, if you have this, okay, what are these if you just follow rule number 1? Okay, iron oxide, but basically the key thing with this one is this is iron 2 oxide because this is, the ion is +2. Okay, so this is iron 2 oxide. That's the rule. Essentially, you use the Roman numeral in here. So essentially, you have the name and then a Roman numeral and then the name IDE. So essentially, the Roman numeral is what goes in there too. Okay, so what is this one? Just do a little math. If this is +2, what's that one going to be? Because oxygen is always -2. Oxygen is always -2. What's the nature of that one here? You have 3 -2s, right? 3 times -2 is equal to what? -6. Now you have 2 of those. So what is that going to make it 0? This is +3. So essentially you have Fe +3. Okay? So this is iron 3 oxide. Obviously, you can't name them both iron oxide. They are both iron oxide, but this is iron 3 oxide, okay? So basically, there are 2 versions of this together, iron 3 and iron 2 oxide there. Okay, yes?
Okay, so how do you know what Roman numeral to use?
What?
How do you know it's Roman numeral?
Well, based on the charge, like this one is +2. One of the things I said is that in these cases, oxygen is always -2, except for one exception, which I'll talk about, okay? And sometimes you have an O2, 2 of them like that, and that's called the peroxide, but that happens for the next rule. Okay, so essentially you have that with the peroxide comes with ternary compounds when I get into that, because per plays a role in those, and that comes on the lecture on Monday.
Okay, so the Roman numeral is based on the charge of the transition metal and the non-metal.
Correct, correct. Yes, like say for example, SNO, this is tin. What is that called? This is called tin 2 oxide. SnO2, what's that going to be? This will be tin 4 oxide. So basically this is +2, -2. This is +4, and so -2 for each. So do you see how it all ends up to be 0? Okay, so that's the third rule there. Yes.
You got the +4 because there's 2 negative charges. The oxygen, you have 2 oxygens and they're both negative.
Yes, that's correct. So the tin there is +4 there. That's why I had in that column, it could be plus or minus 4.
Okay.
So in that case, there's a +2 one there as well. Okay. What? Sorry?
How do you know what's plus or minus? How do you know?
Well, based on the metals are always plus. The non-metals are always minus. Okay? So the non-metals are the ones that are minus. If you look at the chart, the minus ones are on the right-hand side. And that's why I'm going to give you practice problems to work on over the weekend. So that'll serve as a take-home assignment. They're not really a quiz, they're to prepare you. And if you have any questions, you can do that.
Are they graded on accuracy or?
No, I just want to make sure you got them complete and you understand how to do that, okay? So, and the fourth rule is essentially there's a variety of different ones, including common names. And say, for example, UF6 like that, you have a uranium and there, so what is that, what would that be called? Uranium hexafluoride. Okay, so that could be uranium-6 fluoride or uranium hexafluoride. So essentially there are some that are just done that with hexafluoride like that. Now, those of you who are virtual, do you have any questions of me? Anyone there have any virtual questions? Okay, we are done for today. What I will do is put up online some worksheets. I'd like you to have them for the binary compounds finished for Monday. I'm assigning the first 2 worksheets. The other 2 worksheets you'll work on for Wednesday. That'll include the ternary compounds and the rest of them, and that's just a good way to practice. Yes. It's based on the transition metals, yes. So we do have transition metals associated with that.
Will you send us an email before
Yeah, I'll be posting them right when I'm done now. There's 4 worksheets. I want you to work on worksheet 1 and 2 with the binary only. And then the other 4, the other 2, you're going to finish those for Wednesday. That's ternaries, yes. Sure, of course. Okay, did hold on a sec. Did any of you have any questions? We're done now. Any questions? Okay, very good. Thank you. Yes.